All right. Good morning, everyone, and apologize for the delay. So today we're going to talk about methods and for platform SSD-PHY interrupt characterization for server and storage ecosystem. My name is Mamo. I'm in Solidigm, and I also have Pradeep Mishra as well as Frank Voqui. So we're going to talk about the methodology and some of the areas actually where we needed more collaboration as an industry to have the PCIe Gen 5 or Gen 6 actually to make sure that it is out of the critical path. So I want to talk about a bit on the challenges, right? What's been happening on the industry? So how it, with the higher PCIe bus speed is going right now, we're about Gen 5, and then we're going to go to Gen 6 and higher. So currently, what we see in the industry is there's a lot of challenges on channel insertion loss, coupling issues, and crosstalks, and then the factors produce serious platform interrupt challenges and failures. Um, Adding to that, actually, because there's a requirement for the high reach, from the insertion loss. So, a lot of system designers actually have been using, switches, redrivers, retimers. So that basically increases the interrupt issue between the platform and the components actually within it, right? So what we're saying, and also actually on top of it actually is, hey, we got a complexity between the systems. Now it's x86, there is also ARM ecosystems coming in, there. So based on that, actually look at the topology is growing. So what we've seen actually so far is with all limitation, there isn't any capability or platform capability. We can look at the whole PCI topology to understand the upstream, downstream, to make seamless actually integration between our endpoint, which is SSD, as well as retimers, as well as some of the controllers, and right. So it's critical that we had to design kind of an approach that we have a solution from the root complex perspective, as well as all the way to the endpoint. So we're going to talk about some of Solidym's approach, some methodologies, actually how we're going to be having that design. One would be a standalone mechanism. The other one will be a vast, at scale actually, how we can collect all the data to make the PHY characterization work and interrupt working better for the for the platform as well, for the whole solution. With that, I will maybe have us, because the technologies that we're going to be using is call it LMT, which is a PCIe Gen 5, PCIe spec. So we're using that actually, and we double down, and then we kind of creating some other attributes to make SSDs actually seamless actually on the ecosystem. All right, let me introduce Frank. You can take over the next page.
Yes, so with PCIe as the high-speed transport connection, the transmission signal integrity is one of the main challenge to resolve. The signal integrity health is mostly the burden of the PCIe linked receiver, and with the different IPs, the many IPs, there's many different proprietary methods to connect to the sideband to examine the RX health. And with the different proprietary methods, it's not very scalable for large-scale ecosystem interop. So PCIe has provisioned methods for diagnosing signal integrity for system interop, and that is called PCIe lane margining. With PCIe lane margining, the capability, it taps into the PHY circuit of the RX sampler to look at the eye opening, the left, the right, the top, the bottom, to see how open the eye is. And with that, we can assess the link health. And it has a provision to look at the different quality and quantity of the signal. For example, BR from 9 to 6, 9 to the 12. It's the adherence, the IP vendor's adherence to lane margining is good, but the implementation is pretty wide, and it makes it kind of difficult for integrators and validators to use effectively. So there's still a challenge. Solidigm, as an SSD provider, is heavily leveraging PCIe lane margining to deploy and develop as a platform interop solution to approach wide volume validation coverage.
All right, let's take a look at the Solidigm conceptual approach towards mitigating some of these challenges we just spoke about. So what we are approaching here to have a kind of a standalone applications which supports on all supported OS, which is like today it is Windows and Linux-based applications, which can perform all these lane margining tests, and plus it will have a very intuitive GUI interfaces with all kind of features which will be very easy for any users to run as a standalone application and tool and do the characterization on a particular given ecosystem in their particular platform ecosystem, which is like from host, retimer in the middle, and towards the endpoints. So let's take a look at some of those features which I would like to highlight here. Is the first one is like display the entire tree, the PCI topology tree of a particular system. So that gives a flexibility for the users to go select either a device or a group of devices or entire tree view, entire structure of the system. So the user can go select that and then start performing the margining. Alongside that, it can also have a different LTSSM events introduced during each cycle of lane margining test. So we can have a tool where it can have all the list of LTSSM events such as SBR, FLR, link enable and disable, retrain, and so on. Again, it is up to the user what they want to do it. The idea there is to initiate the selected link event before doing each cycle of lane margining to get a robust and a consistent lane margining data. Because sometimes it happens, okay, first time we run it, okay, we get some data. Okay, how about we run it a different iteration with multiple different link events, because different link event will equalize the links in a different way. Equalize settings will be different. So that's why this is very important to have that different equalization settings. Then provide options to do a multiple runs. So it's not just one. User can select 10, 100, whatever they want to do it, just to have consistency on the results. And then when we run these many of tests on these n number of drives and parameters, the data it's going to produce is enormous. It's huge data. So provide a filter mechanism where user can go select what they want to see. They can collect the entire data, but for analysis purpose, they can select few or whatever, depend on their choice. Just select only SSD data, just to see SSD and analyze how it is performing and behaving in this situation. Similarly, move it to the next host system, retimer, and so on. So that will help them to analyze and debug this lane margining approach. And then utilize the OS level features, which are like all multiple threadings, parallelism, and all these. Utilize these benefits into this tool and have a great tool. So this slide here, we can see this is a pictorial representation of all these features I just explained. So you can see on the left side, device tree, listed all the device. Right side, there are some LTSSM events. And when we go run the margining, it should generate that kind of eye. So you can see it's wide open, and it shows, yes, it's pretty good. And there is a mask provided in middle that is based on the PCI guidelines, a minimum mask. So when we have these kind of tools, so this tool can be used for like SSD vendor tools. It can call out multiple uses of tool. These are the different uses. System can use for different ODM validations tools, regression tools. This can use it, run for different regressions, and so on and so forth. So, yeah.
So in this graphics, we show a possible topology and a platform setup where we're looking at multiple racks distributed all over a building, and with the lane margining method and building an application on top of it, we can run in parallel and assess all the link health of different racks, different drives, different rooms all together. So that's a vision that we have to try to leverage the lane margining approach so that we can get health across the whole ecosystem.
Great, thanks, guys. So the call to action is, as you guys looked at the whole thing actually from topology perspective, the lane margin capability actually is a key for us actually to go wider. We're asking every specifically primarily silicon providers, ODM, OEMs, to use this implementation to go wider onto that, right? So that we have a better capability, and also actually it gives you the whole topology of the PCIe map, right? As we said, right, from all the way from the root complex to all the way to the endpoint, which is our SSD, and then that gives you give us the data actually to characterize whichever ways you want to do from upstream to downstream perspective. So it's more prevalent actually using the industry to really promote commodity and nature interoperability for the OCP. So really thank you guys for coming in our presentation, and we're going to be in Solidigm booth C1. If you guys have any more details, questions, or anything that you want to discuss on that. Thanks.
Thank you.